Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x is equal to 7 to the power of x plus 2. And I actually have 2 different methods to solving this problem. So for method 1, so we obviously start with 3 to the power of x is equal to 7 to the power of x plus 2. Now, 7 to the power of x plus 2, well, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, a is equal to 7, m is equal to x, and n is equal to 2. So 7 to the power of x plus 2 is equal to a to the power of m, so 7 to the power of x, times a to the power of n, so 7 to the power of 2. So now putting it all together, I have 3 to the power of x is equal to 7 to the power of x times 7 to the power of 2. Now I'm going to go ahead and divide both sides by 7 to the power of x. So then these two will cancel out, and I will be left with 3 to the power of x over 7 to the power of x is equal to 7 squared. Now if I have something in the form a to the power of m over b to the power of m, this can be written as a over b to the power of m. So in this case, I have 3 to the power of x over 7 to the power of x. I can think of a as 3, b as 7, and m as x. So I can write this as a over b to the power of m, so this would be 3 over 7 to the power of x is equal to 7 squared. Now, 7 squared, this is 49. So I have 3 over 7 to the power of x is equal to 49. Now, I'm going to take the log on both sides. So now I have log 3 over 7 to the power of x is equal to log 49. And if I take the log of a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. And the same thing is also true for natural logs. So ln, if I have ln a to the power of b, I can move this exponent b to the front, so this would equal b times ln a. And the reason this property is so useful is, let's say I have 5 to the power of x is equal to 7, right? Now, in the form it is, x is an exponent, and we can't really find the value of an exponent because we need it to be a real term. So now, if I take the log on both sides, I can now move this exponent x to the front. So now this would be x times log 5 is equal to log 7. Now I can divide both sides by log 5. These two cancel out. And as you can see, now I found my value for x. Before, when it was an exponent, I really couldn't. But now, after I use this property, x is a real term. So that's why this property is so useful. So now going back to the original problem, I had log 3 over 7 to the power of x is equal to log 49. And I'm going to actually take the log of base 3 over 7 on both sides, not just normal log. And now I can move this exponent x to the front. So now I have x times log 3 over 7, base 3 over 7 of 3 over 7 is equal to log base 3 over 7 of 49. Now, if I have something in the form log base a of a, this is simply equal to 1. So in this case, I have log base 3 over 7 of 3 over 7. These two cancel out, so I'll be left with x is equal to log base 3 over 7 of 49. Now, we could actually simplify this a little. If I have something in the form log base a of b, this is the same thing as log b over log a. So this would equal log 49 over log 3 over 7. Now 49 is the same as 7 squared, so now I have log 7 squared over, if I have something in the form log a over b, this is equal to log a minus log b. So log 3 over 7, that's going to equal log 3 minus log 7. Now I can go ahead and move this exponent to the front, so now I have 2 times log 7 over log 3 minus log 7. So this is our answer in simplified form. Now for method 2 of solving this problem. So I have 3 to the power of x is equal to 7 to the power of x plus 2 as my original equation. Now I can take the log on both sides. And now I would have x times log 3 is equal to x plus 2 times log 7. Now I have x times log 3 is equal to, now the x and 2 distribute, so I have x times log 7 plus 2 times log 7. Now if I subtract x times log 7 on both sides, I have x times log 3 minus x times log 7 is equal to 2 times log 7. Now if I factor out x, I get x times log 3 minus log 7 is equal to 2 times log 7. And now if I divide both sides by log 3 minus log 7, these two cancel out, and I will be left with x is equal to 2 log 7 over log 3 minus log 7. So these are the two methods of solving this equation. Alright, so in this video, I'm going to be solving the equation x squared minus x to the power of 3 is equal to 12. So to start, our only variable is x in this equation. So I want to find the value of x. And for my solution, I'm going to first start by rewriting 12 as 4 plus 8. So I get x squared minus x to the power of 3 is equal to 4 plus 8. And the reason I did that was because 4 is the same thing as 2 squared, and 8 is the same thing as 2 to the power of 3. So notice I have a number squared minus a number to the power of 3, and then I have a number squared plus that same number to the power of 3. Now I'm going to subtract 2 squared on both sides and 2 to the power of 3 on both sides. So these two cancel out, and I get x squared minus x to the power of 3 minus 2 squared minus 2 to the power of 3 is equal to 0. Now I'm going to group all the powers of 3's and the powers of 2's together. So I get x squared minus 2 squared minus x to the power of 3 plus 2 to the power of 3 is equal to 0. So if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So x squared minus 2 squared is going to equal x plus 2 times x minus 2. And now if I have something in the form a to the power of 3 plus b to the power of 3, this is going to equal a plus b times a squared minus ab plus b squared. And these two properties are really important in algebra, so I would recommend memorizing them. So now I get x plus 2 times x minus 2 minus x plus 2 times x squared minus 2x plus 4 is equal to 0. Now notice how both of these terms have x plus 2 in them. So if I factor out x plus 2, I get x plus 2 times x minus 2 minus x squared minus 2x plus 4 is equal to 0. And this turns into x plus 2 times x minus 2 minus x squared plus 2x minus 4 is equal to 0, which equals to x plus 2 times negative x squared plus 3x minus 6 is equal to 0, which turns into x squared minus 3x plus 6 is equal to 0. Sorry, it's not. This is still negative x squared plus 3x minus 6 is equal to 0. Now from here, this gives me two equations. X plus 2 is equal to 0, and negative x squared plus 3x minus 6 is equal to 0. So for x plus 2 equals 0, I can subtract 2 on both sides, and I get x is equal to negative 2. Now for negative x squared plus 3x minus 6 is equal to 0, now I can divide both sides by negative 1. So I get x squared minus 3x plus 6 is equal to 0. So now to solve this quadratic equation, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get 3 plus or minus the square root of 9 minus 4 times 1 times 6 all over 2a, so 2 times 1, which is equal to 3 plus or minus the square root of 9 minus 24 over 2, which is equal to 3 plus or minus the square root of negative 15 over 2, which is equal to 3 plus or minus the square root of 15 I over 2. So these are two other solutions to my equation.